Our core objective today is to move beyond calculation to interpretation. We want to be able to look at a spreadsheet and see the human story behind it. This represents a fundamental shift. Mechanical calculation is about getting the math right. Contextual interpretation is about getting the meaning right. You can have a mathematically perfect model that is completely wrong about the real world because it ignores context. We call this risk contextual blindness. It happens when we get so focused on the precision of our decimal points that we forget the environmental, social, or historical conditions that created the data in the first place. So, how do we do this? We start by viewing statistics as a tool for pattern recognition. We aren't just hunting for significant stars to put in a journal article. We are looking for patterns within systems. When you look at your data, ask yourself, what systemic behavior does this trend indicate? Is this an isolated incident, or is the system designed to produce this result? This gives us the macro level view. It answers the what and the how much. For example, if you see a spike in asthma rates in a specific zip code, that's a pattern. The statistic identifies the pattern, but it requires you to look at the system, zoning laws, traffic density, industrial pollution, to understand it. This leads us to contextual inference. Standard statistical inference asks, can we generalize this finding to the population? Contextual inference asks a different question. Does this result make sense given the local conditions? You cannot divorce your findings from the environment where the data was collected. If your survey shows that people in a war zone are highly resilient, does that mean they are happy? Or does it mean they have no choice but to keep going? Context changes the meaning of the number. If you find a correlation between two variables, you must immediately look at the context to see if there's a third, invisible variable driving both. I want to warn you again about the trap of reductionism. It is incredibly tempting to reduce a complex human life to a single data point. We do this for simplicity, but it comes at a cost. When we reduce a student to a test score or a patient to a diagnosis code, we strip away their interconnectedness. We lose the reality of their family, their community, and their struggle. Our imperative as transdisciplinary researchers is to maintain the integrity of that complexity. When you report a number, you must also report the web of connections that holds that number in place. A number never exists in a vacuum. It exists in an ecosystem. Now let's talk about significance. In Stats 101, you learn to look for a p-value less than 0.05. If you found it, you celebrated. But in the real world, a result can be statistically significant but practically meaningless. With a large enough sample size, you can prove that a tiny difference is significant. But does it matter? Does it change anyone's life? In transdisciplinary work, we focus much more on effect size, the magnitude of the impact. We care about the size of the change, not just the probability of it. Conversely, a non-significant result can be hugely important. If you implemented a massive intervention and saw no asterisk significant change, that failure tells you something profound about the resilience of the system you are trying to change. We need to treat our data as an ecology. Variables are like species. They interact with each other. In a traditional lab experiment, we try to control for noise and confounding variables to isolate the thing we are studying. But in complex social systems, that noise is often the context we need to understand. If you control for income, education, and location, you might isolate a variable, but you've created a theoretical situation that doesn't exist in the real world. We must resist the urge to isolate variables to the point of irrelevance. We need to study the ecology, not just the specimen in the jar. When it comes time to write up your findings, you have a responsibility. You must be radically transparent about the limitations of your dataset. Don't hide the flaws. Frame your numbers as indicators, not absolute determinants. A test score indicates performance on a test. It does not determine intelligence. A crime rate indicates reported activity. It does not determine the morality of a neighborhood. Use your narrative text to wrap the statistics in the necessary social context. Never let a table of numbers stand alone without the story that explains it. That is how numbers get weaponized. Part of this responsibility involves critiquing standard metrics. We need to ask, are these metrics reinforcing existing power structures? For example, GDP is a standard metric for economic health, but it often increases after a disaster because of rebuilding costs. It measures activity, not well-being. We also need to look at aggregation. Does the average hide the suffering of the margins? If the average income in a city goes up, but the poor get poorer while the rich get richer, the average is a lie. Contextual analysis requires disaggregation. We must break the data down to see subgroups clearly, ensuring that the reality of the most vulnerable is not smoothed over by the math of the majority. To synthesize this lesson, quantitative analysis is vital. It provides the skeleton of our research. It gives us the structure and the scale of the problem. It tells us where to look and how big the issue is. But it has a hard limitation. It does not provide the flesh. It cannot fully capture meaning, emotion, or lived experience. We can infer those things from context, but we cannot measure them directly with a ruler. This limitation is exactly what necessitates our move toward qualitative meaning-making, which we will explore in the next lesson. To summarize, Lesson 4.1. Use statistics to identify systemic patterns, not just isolated facts. Strictly maintain the context during all your hypothesis testing. Never let the math override the reality on the ground. And finally, ensure that you never strip data of its social interconnectedness. The number is only true if the context remains attached to it. Thank you.